The only person you are destined to become is the person you decide to be. Ralph Waldo Emerson. Welcome back to our SQL series. Today, we'll be putting that quote into action by practicing SQL string functions with exercises ranging from beginner to brain teaser. By working through these practice problems with varying difficulty levels, you'll not only solidify your understanding but also ace those technical interviews. Before we jump right in, a quick recap. String functions are applied to text data. Some of the frequently used functions are upper, lower, length, substring, position, concat, replace, reverse, trim, ltrim, and rtrim. Now let's begin our practice with queries of simple difficulty. First SQL query in our simple difficulty level, update the message SQL is fun to SQL is great. So you need to write a SQL query that overwrites the message SQL is fun to SQL is great. So the only actual change is to overwrite fun with great. So you get your expected output. You're dealing with a string. So which string function comes to your mind hearing about overwriting a string? Replace. Use a replace keyword to change from fun to great. Let's write that. If you don't have PostgreSQL on your system, please install it to leverage its powerful open source database capabilities for your SQL practice. Follow our installation video for step-by-step instructions. Open PostgreSQL. Let's copy our query here. Now you know the string to be changed, that is SQL is fun. What is your replace syntax? This is your replace syntax, right? Within the function, let's pass your input, that is SQL is fun. What do we want to replace? Fun. What is the replaced string? Great. So within the replace function, input string, string to be replaced, replaced string. Let's execute it. See, SQL is great. For you to see more clearly, place the original string here. Give an alias name as original string, comma, the one under the replace clause as replaced string. So now you can see original string as well as replaced string. Let's execute it. See, SQL is fun to SQL is great. This is your simple replace query. Next query, find the position of SQL in Hello SQL world. Which string function to be used here? The hint is in the question itself. Position function. Let's open PostgreSQL to write a SQL for this. If you don't have PostgreSQL on your system, please install it to leverage its powerful open source database capabilities for your SQL practice. Follow our installation video for step-by-step instructions. Place the question here so you don't deviate from it. What is its syntax? Select position. Not only that, now string, you want to identify the position, which is nothing but SQL. In is the keyword again in the larger string, Hello SQL world. So this is your query. Select position of the string that you want to find the position in the actual larger string. Do you want to give an alias name here? As SQL position. Execute it. See, 7th position. Remember the index of the actual string? Count the characters. 1, 2, 3, 4, 5, 6. It starts from 7th position. That's why you see the output as 7. So that's our simple query for a string function position. Next, reverse the order of characters in the columns name and address of the table text data. I'll share the DDL scripts to create a table named text data and insert relevant data into it. So you can leverage the dataset for your string functions practice. Place the question on your SQL editor in the comment section. It's always a best practice to have the question right in front of you, even in your interviews. It's natural to get distracted as you are building the query. As long as you have your question right in front of you, one less thing to worry. You can happily focus on building the query, and whenever you get distracted, you can come back and read the question as you build the SQL. You got the tip for the day. Coming back to our SQL, what is the syntax of reverse? I think reverse is one of the simplest syntax among the string functions. Just place your name and address. But before that, let's see what is there in the text data. So this is the data from your text data table. Your question is to reverse the order of characters in the columns name and address. Let's place reverse of name, give an alias name. Similarly for address. For clarity, let's have the original name and address as well. Name and address. From the table, text data. Execute it. See, here are our original names and these are the reversed names. The entire column value got flipped. So this is the simple reverse query. Now, let's move to the next level with medium difficulty questions. Let's say you have a text description in mixed case, and the text is SQL is fun. Write a SQL query to convert the first part to uppercase and the remainder to lowercase. Time to open PostgreSQL. Let's have our question here. If the ask is to either convert the whole string to upper or lowercase, then it would have been easier. But here there are two parts to the question. One, convert the first part to the uppercase and then the remainder to the lowercase. There are two parts. So two conversions have to be done separately. So for the separate conversions, separate extractions have to be done. How do you extract a part of the string? Which string function you can use? Yes, substring. Let's use that. Select substring of, place the entire string here. String, starting position, and how many characters you want. Starting position is 1 because the index of the string starts from 1. And we need SQL out to convert it into uppercase. SQL holds 3 characters. So we need 3 characters starting from first position. We were able to extract SQL. What is the next extraction? The remainder. Again substring. Let me copy this. This time it is not 1 comma 3, right? So the starting position is 4. Of course, you'll not get it differently whether it is 4 or 5 because fourth index holds space. And you don't even have to actually count the characters here because you want to extract the remainder, right? So it is not necessary to mention the number of characters. If you don't mention anything, it takes all the characters starting from fourth position by default. We are almost ready. We have extracted the strings. Now it's only conversion that is left out to upper and lower. You can directly add upper and lower function to these substring functions. We said medium complexity, right? So this is the level of, so this is how multiple functions can be used together. All right. You have your query ready? Let's see if we get any syntax errors by executing it. No errors. And this is exactly what we want. Convert the first part to uppercase and remainder to lowercase. There you go. The key to write SQL query is to understand the question first. Next, create a summary of a document column in the text data table. How do you write the summary? Your summary should be first 50 characters of your column value followed by 3 dots. So you need to write a SQL query to extract the first 50 characters from the document column and append 3 dots. Let's see how. Open PostgreSQL. Here is your question. Extract the first 50 characters from a document and append. Output 50 characters plus 3 dots. So you're combining something. The function to pick is concat. Let's write the query. But before we write, let's quickly see what is there in the table text data. Here is the data, and this is the column document from which we are fetching first 50 characters. Start with select, concat of first 50 characters. For combining, yes, you need concat operator. But to extract first 50 characters, what do you need? Substring. With substring, we'll get 50 characters. Let's also add 3 dots. If we could extract 50 characters, that's all. We are ready to fetch. Substring of the column name, document, comma, first 50 characters. First itself is indicating the starting position is 1. 50 characters. Length of the string. It's almost a direct question. Substring of document, the column name. First 50 characters should be fetched with these index numbers. Starting position and the length of the characters, comma, the 3 dots from table name. Let's execute it. See, first 50 characters, comma 3 dots. Wherever the length of the column is less than 50 characters, it fetches the existing length. So now, how do we know whether the fetched characters are 50 or not? Instead of manually counting it, let's apply another string function on top of this so you can fetch the length of it without manually counting. So the idea is to validate whether we really got the output of 50 characters plus 3 dots. So the expected length should not be greater than 53 characters. Then our query is correct, right? Let's do this. I applied length on top of this. I want to see the string side by side, so I have added the concatenated text as well. Let's execute this now. See, this is the only one value which has more than 50 character length. Rest all has less. So it retrieved whatever the existing length is. Our query is correct because though this column value is more than 50 characters, we have got only 50 characters plus 3 dots. So that's the SQL is all about. Moving on, say this is your input table. From this, write a SQL query to create a unique identifier by combining the columns name and ID and extract the domain from the column document. So you need to generate a unique identifier for each record by combining the name and ID separated by a hyphen. Additionally, extract the domain part from the document column. Let's open the SQL tool. Let's have our question right in front of us. Even in this question, there are 2 parts to it. One, to combine the name and ID separated by hyphen to extract the domain part from document column. Let's focus on the first part. But before that, let's see what is present in our table that we are going to use for querying. Text data table has the columns ID, name, address, password, document. But for this query purpose, we are using the columns ID, name, and document. To get the first part, it is asking to combine name ID in between hyphen. So this is the format that you should retrieve. What is the function that you're going to use for combining strings? Concat. Let's use that. Select concat of what? Name, comma, ID. Separated by hyphen. Hyphen is not a column name, right? It is a constant value. So put it in strings. Hyphen, comma. So this is what exactly you want from the table text data. Now let's move our focus to the second part of the query, that is extracting the domain part of the document column. For readability purpose, let's get it down. The word extracting a part is synonymous to which function? Substring. So substring of, you are applying on a table on a specific column. The values in the document column are text-like values. You cannot really hard code the index numbers as 4 or 5 to get these domains. The best way is to locate this domain dynamically. The word locate is synonymous with which function? Position function. So instead of giving the index number, I want to use position function to dynamically retrieve the index of that particular domain part. Position of what? If you could identify the forward slash, then it is easier for us to pick the domain name. Position in document column. This is the syntax that I am writing. Since we want the domain name from starting from this forward slash, we can leave it as is without giving the second part of the syntax. So by default, it will take the entire name. But do you think it gives the output as example.com and example.org without having the forward slash as prefix? We can do the necessary modifications later. For now, let's keep it this way. As domain name from the table, text data. Name ID. Let's execute this. If you see the first part, name and ID separated with hyphen. Perfect. Additionally, what we want? Extract the domain part. But what to do if we don't want these forward slashes? There are multiple ways to avoid these forward slashes, but the simplest way, it is index, right? So this retrieves the starting index from where it has to extract. Since it is the number, let's add 2 characters to it. So it will eliminate 1 and 2, these 2 characters, and it will give us only example.com and example.org by removing these forward slashes. Let's execute this. See, now we got the way we want. But you might be wondering, we want only the example.com and example.org with this substring and position. Why are we even getting all the other values in the domain column? Because we didn't apply any filter to avoid all of the other records. So if you want to see only example.com and example.org, the simplest way is to filter them. How do you apply filter? With where condition. Percentile. I'm telling the tool to get me this particular strings, but only where you identify the forward slash. This should bring only example.com and example.org. Sorry, the column name is not domain, document. Here you go. We are climbing the complexity ladder slowly but surely. Last one under medium complex category. Split the name into first and last names. Again, we are referring to string extraction. So the obvious function to use is substring. Let's use that. Here is the question. Let's view our data in text data table before we come up with the query. This is the name column which we want to split into two parts, first name and last name. So you already got the string function that we can use here, substring. Let's use it. Here there is a catch. Do you think only substring function can help us split the name column? No. Substring function alone cannot help us with the split on the column because the values are dynamic. We cannot use index numbers. One thing that is column across the data is space. One thing that is common across the name values is space. So there you got the hint. How can we identify this space? Using position function. That means you need both substring and position functions to do the job. So let's have the column added here. Name. First, let's retrieve the first name, which anyways will start from first position. So starting index is 1. Length, we cannot put a hard-coded number because like we just discussed, it varies. So here the position function helps us locate the space, position of space in name column -1. Let's see with an example how it works. Let's take this example John Doe. So instead of name column, I have taken the example value John Doe. Next, starting index 1. Length is position of space, right? Position of space in John Doe. This will retrieve 1, 2, 3, 4, 5. So this will retrieve 5. But we don't want 5 characters, right? If we use 5 characters, then the space will also be added. We want only till n. That's why we have added -1. -1. So this -1 will cut the space by fetching the length of the characters as 4 here. Let's execute this so you'll understand what exactly we are talking about. Let's put it in quotes. John. This is exactly we are applying on a table. Let's give an alias name as first name, comma. Now let's write the last name. For the last name, you should be using substring function, no doubt about it. Name, this has to be changed. The position is used as the length of the string for first name. Here that won't work because it has to start from the space to fetch the last name. Let me execute this to show you what exactly I'm talking about. See, last name should start from this space, not exactly from this space, but one position after the space. So that's why I'm adding +1. Okay, now we have the starting index. What is the length? Here we don't necessarily have to give the length. Remember, by default, it fetches all the characters if we don't provide the length value in the substring function. So we can leave as is. Let me execute the same on the constant, then we can execute it on the table. Instead of name, let me put it John Doe. We have got it because the position function identified the space, which in turn helped us to fetch only the string that we want to retrieve. So likewise, we'll apply on the table too. From text data table. Execute it. See, we are simply applying the logic to identify the values that we want to extract the strings. Substring and position or in string are the most frequently used string functions in real time. You got the result. Moving to the next and last segment, complex queries. Under that, write a query to extract the initials from the name column. For example, if the name is John Doe, the result should be J.D. Interesting, right? Let's see how. Question on the editor screen. It's always easy to come up with a SQL query if you can break the question down. Let's break it down. Step 1. Get the first initial. If we take the same example, it will be J. Step 2. Get the second initial. It is D. Step 3. Add dot to the first initial. Then it becomes J dot, the step 4. Add dot to the second initial. Now you need to combine all these 4 steps. That's all. Before we write the query, let's do a select star from our table, text data. In this table, our focus column is name. Let's get the first part, that is first initial. By this time you should get the function name. Yes, substring. Syntax of substring is column name, starting index, and length of the characters. First initial is always the starting index will be 1, and we need only initial. Easy. So the number of characters is also 1. With this, your part 1 is completed. Coming to part 2. Again substring. Syntax, column name. Let's think for a moment to extract the second initial. Again, with the hard-coded number, we cannot fetch the index of every value because the last name starts sometimes at 6th character, sometimes at 7th character. We never know. It is dynamic. In that case, we go with the pattern of the data. For sure, the space is expected before the last name. So that is our hint. But how do you locate the space? Position. Pick the space in name. Now you know the space, but you don't want starting from space, right? So do a +1 so that the starting index will be after the space. Now the length of characters. It is simple because the ask is on the initial. Length is 1. Before we build the query with part 3 and 4, let's see if there are any syntax errors with the query that we have built so far. Perfect. There are no syntax errors and we have got the data as expected. Let's build on top of this. Part 3, add dot. How do you append dot? Using concat function. This initial comma dot. Dot should be in your quotes, comma. Same for step 4. Comma dot in quotes. Step 3 and 4 completed. Before the final step, let's execute this and see for any syntax errors. Perfect. Now do a big concat of all of this. Give an alias name as initials. But to assess if we get the correct initials or not, let's add the name column as well. Let's see. See? John Doe, J.D. Li Smith, A.S. We got the result. You can further improvise the query. How? You don't necessarily have to use multiple concat functions. Even if you combine once or multiple times, it is only one concatenation. So let's remove and see how it behaves. Let's remove this concat. By removing the concat function that we used inside, you still get the same result. Your query becomes efficient when it uses optimal keywords. We did it. Next one, write a query to mask the password column. showing only the first and last characters and replacing the rest with asterisks. For example, if the password is password 123, the result should be P all asterisks and 3. Let's check. Place your question. Let's simplify the question by breaking down into steps. Here are your 4 steps. Step 1, you're getting the first character P. Step 2, replacing the middle characters. This is step 1. Step 2, replacing the characters between first and last characters. Replacing the in between characters with asterisk. Third one is getting the last character, and combining all the above will give you the required output. Let's start. You already know by this time how to get the first character. If not, I would recommend watching the other videos with the simple queries. Just a second. Before writing it, let's execute the table and see the data in it. Our interested column for this question is password. Alright, let's continue writing our query. Select substring of column name password, comma, starting index, comma, required number of characters, right? Your starting index is 1 and you need only one character, the first one. So that is also 1. You're done with step 1. Your step 2 is replacing the middle characters. Step 3 is get the last character. Let's finish the step 3. Then we'll come back to step 2. Step 3 is again substring function because we are extracting last character. Password. Since the last character is dynamic, changes from value to value, you don't know where it starts. In that case, using a length function will help us. Length of password will give the length of number of characters. Say for example, 8 characters of this value. So 8th character is D. That's what we want. So the starting position is length of password and the number of characters that we want is 1. So you can keep it. This gets you step 3, last character. Circling back to step 2, replace in between characters. In this case, what do you think the function that has to be used? It is definitely not replace. You can use replace, but it would be complex. There is one more direct built-in function you can use in case of these repeated occurrences. That is repeat. The syntax of repeat function is the characters you want to replace. Column name. What is the replaced string? Asterisk. How many times you want to repeat? Except 2 characters of the length of the password. So use the length of the password. Let's execute this and see for any syntax errors. Column name is not necessary here. Perfect. Now all we need to do is combining these different values. So concat of starting parenthesis and ending parenthesis as masked password. Let's see the original password and masked password. Execute it. There you go. You got your password masked using this SQL query. You're almost at the finish line. Let's take on this final challenge to finish strong. Write a query to extract both the house number and the street name from the address column. For example, If the address is 123 Main Street, the result should be 123 for the house number and Main Street for the street name. Let's jump right in. Question on the tool editor. Before we actually get into the SQL query, let's see how the address column looks like in the table text data. This is the interested column. All these numbers should come under house number and the names under house names. The obvious function, substring. Since we are applying on the table, you would need to use substring in combination with position function. Let's begin. Select substring of address column. First, let's fetch the house number. For that, the starting index is always 1. Until how many characters? Here it is clearly visible that it is 3 characters. Say for example, this 3 characters is not set in stone. It could be varying. Let's make our query complex by assuming the house number as a dynamic value. In that case, logically, how can you extract the house number? You can use, all you need to tell the query is how many numbers, right? So first, let's identify space. Position of address -1. Because with position of address, it exactly gives the index of the space. But we need the value just prior to that space. So we are subtracting 1 from the index of the space here. Say for example, in this case, with position of space in the address, you get 4. 4 minus 1 is 3 characters. So address comma 1 comma 3 should give us 1, 2, 3. No matter the length of the house number, it works in all cases. All right, next one, fetching the street name. Before that, let's give an alias name as house number. Moving to the street name. Again, substring of address. Here it doesn't start from position 1 or any hard-coded position. The same case, right? So what do? Use the position function. So the trick is whenever you can't hard code the index number, then use position function. So in these cases, any complexity can be resolved with 3 functions. Substring, position, sometimes length comes to your rescue. All right. Copy the starting index as position function. Here instead of -1, use +1 because you want after space, not including the space, right? Here position of this space gives you 4, +1 gives you 5. So the starting position will start from the actual street name. And you don't have to give the number of characters because substring syntax itself gives you an advantage with the default value of giving all the characters if you don't specify length of the value. Give an alias name as street name. We should not be getting any syntax error. But let's check it out. Typo in address column. There you go. You got the numbers under house num, names under street name. You got the result. And with that, we have reached the end of our practice problems. For any questions and clarifications, please reach out through the comments below. As we wind up, let's get inspired by Bruce Lee's words. I fear not the man who has practiced 10,000 kicks once, but I fear the man who has practiced one kick 10,000 times. Keep practicing and you'll be unstoppable.